All right, our technology activities for Chapter 8, using the graphing calculator and doing some stuff on Aleks just to see how both of those work. We're going to do a hypothesis test for the mean using the Z distribution where the population standard deviation is known. You may have a list of data or you may just have the statistics from the word problem. So what we're going to do if we have a list of data is we're going to enter the data into list 1 by pressing the stat button and 1 for edit like we've been doing before. Once we have our data in, we're going to press the stat button, cursor over to the word tests, and then we're going to do choice number 1, which is our Z test. Depending on if you are using your list or using the statistics, if we're using the list of data, we're going to cursor over to the word data and press enter. If we have the statistics, we're going to use that. We'll do it both ways. Type in your appropriate values for the mean and standard deviation, and then move your cursor to the appropriate alternative hypotheses and press enter, and then move the cursor to calculate. Now, when you are doing your hypothesis testing, you also will need to find the critical value for your Z-score. This is what you did in Chapter 6. So before we do our hypothesis testing, just to remind you how to find the critical value, for the Z-score on the graphing calculator, we're going to press second, the DISTR button, and then number 3 for inverse normal. On Aleks, we're going to do either plus or minus Z sub and whatever the score is. So, grabbing my graphing calculator here, and I got to clear it out. So if I have my graphing calculator, again, just to remind you from Chapter 6, we're going to hit the second button, which is the blue button. We're going to hit the distribution one, so the VARS button, the VARS, to get the distribution menu, and then number 3 is your inverse normal. Under for the area, you always want the area to the left. So in this case, if we're finding the area to the left of 0.7123, we're going to put 0.7123. The mean and the standard deviation, since it's a Z1 and we're doing the normal curve, will be mean is 0, standard deviation of 1. Paste that into my formula. So I have it in my formula. When I hit enter there, you should see that we get 0.560116461. Normally they'll have you round it off to 3 or 4 decimal places, just depending on the question. So make sure you pay attention. They'll usually say at least 3, and if you go farther than 3, you're okay. If we are doing that on the Aleks calculator, I'm going to bring up my Aleks calculator here and clear that out of there. Again, when we use the Aleks calculator, if we want to do the area to the left, we're going to do negative Z sub. So I'm going to do negative Z sub, and I'm going to put in my 0.7123 and hit equals. And you see we get that same value that we had, the 0.56011, so forth. So I'm going to go ahead and have you try the next one. I gave you the directions for both the graphing calculator and on Aleks. Do it both ways. You should get the same answer both ways. So go ahead and try to find the Z-score for the area to the right of 0.1234. All right, so now that we know how to find that critical value, or we've refreshed our memory on finding the critical value, we'll go ahead and do the hypothesis testing. So it says here, for a specific year, the average or mean score on the SAT math test was 515. The variable is normally distributed and the population standard deviation is 100. The same superintendent in the previous example wishes to see if her students scored significantly below the national average on the test. She randomly selects 36 student scores as shown at an alpha value or a significance level of 0.10. Is there enough evidence to support the claim? So At the 10% significance level, test the claim that the mean is less than 515, given the data values. So what we want to do on the graphing calculator is put our data values into our list. And so if I'm on my calculator here, I am going to hit the Stat button. I'm going to push number 1 to edit, and then I'm going to enter my list in. You can see that I've already entered the list in, but go ahead and pause the video for a little bit. Make sure you accurately get all of those values typed in. So once you have the values typed in and you want to do your hypothesis testing, what you're going to do again is just press the Stat button. When I hit the Stat button, we've done the edit and we also calculated one variable statistics, but you can see there's a menu called Tests. Those are going to be our different kind of tests that we're going to do, which in this case, we are going to do a z-test, and so we're going to do number 1. Now, you have the choice of either to input the data or the statistics. In this case, since we're doing the data from list 1, you want to have data highlighted. If it's not, enter on data. The mean that we're comparing to is that we want to be less than 515, so we're going to put 515. The standard deviation, the population standard deviation, is 100. For the list, we put our data in list 1. The frequency, you're just always going to leave at 1, and then you want to highlight what your alternative hypothesis is. In this case, we were testing that the mean is less than, and so we're going to pick the middle one and enter on that one. Now, just for fun, if you happen to go to draw instead of calculate, I've been having you just do calculate, but for fun, if I did draw, it's going to draw me a picture of my standard normal curve, the blue part being the part that is in the critical region there. So I want to actually have my data, so I'm going to go back and I'm going to hit Stat again and go to my tests, and number 1 for my z-test, it's going to have my information in there that I just typed in. So this time, instead of drawing it, I'm going to go to calculate. When I go to calculate then, it is going to give me the z-score, the p-value, and then my mean, my sample standard deviation, and how many numbers I had there. What we need to do on this one is we want our test statistic and our p-value. On Aleks, sometimes they will ask for the test statistic, sometimes they will ask for the p-value. So my test statistic, rounding to 3 decimal places, would be 0.3, or negative, I better forget my negative in there, negative 0.358. Negative 0.358. My p-value is 0.360. 0.360. So we have to decide, is this a left-tailed test or a right-tailed test? In this case, since I'm doing a less than, it is a left-tailed test. Then I have to figure out my critical value. So again, in order to find your critical value, you can either use the Aleks calculator or your graphing calculator. If I use my graphing calculator again, I am going to do the second function and the vars key to get the distribution menu, and I am going to do the inverse normal, so I'm going to do number 3. And so I want to find my critical value there, 0.10, and I'm going to paste that in. And so my critical value there, you can see when I did inverse normal of 0.10, because I was doing the 10% for my alpha value, is negative 1.282. Negative 1.282 is what I get. Again, if I use the Aleks calculator over here to find my critical value, I'm doing z sub. I have to actually do negative z sub because I'm doing the area to the left. Negative z sub 0.10, and when I hit equals, you can see that I get the negative 1.282, just like I did on my graphing calculator. So either way, I can get my critical value by using the graphing calculator or using the Aleks calculator. If it's area to the left, I'm going to do negative. If it's to the right, I'm going to do positive. So my critical value, negative 1.282, rounding that off to 3 decimal places. So now the question says, if the level of significance is 0.10, 10%, should we accept or reject the claim, and why? So this is where you have to do some thinking about where that value lies. Let me go ahead. I'm going to put my answers back in there. So my critical value, since I have that up on my calculator screen, was negative 1.282. And going back on my calculator and looking at my test statistics, I'm going to hit Stat, Tests, my Z-test, and recalculate that. We said our Z-score was negative 0.358. And we said our p-value was 0.360. We said that we were doing a less than, so this one is your left-tailed test. So, 2 ways we can figure out if this is significant or if we should accept or reject the claim. One way is by comparing the test statistic to the critical value. If I think about it, my critical value is negative 1.282. My test statistic is negative 0.38. The negative 0.358 happens to be greater than my test statistic, which is negative 1.282. Which means if I'm looking at my normal curve, that my test statistic is in the null section of my standard normal curve. I'm going to show you what I have drawn on my paper here. And so there's my standard normal curve. If it falls in the critical region, which is the region to the left, then it would be the alternative hypothesis. But if it falls to the right, in this case, it's going to have the null. So what we would do is accept what the null hypothesis was. So if we accept the null, it means we are going to reject the claim, because the claim was the one that was less than. Now that's one way we can compare by looking at that value compared to the critical region. The other way is by comparing the p-value. If I look at my p-value is 0.360. 0.360 is going to be greater than the alpha value, which was 0.10. If my p-value is greater than my alpha value, I'm going to accept the null, which means we end up rejecting the claim. So I've typed in the answers there to that one. The test statistic was negative 0.358. The p-value, 0.360. It was a left-tailed test. The critical value was negative 1.282. And then, should we accept or reject the claim? Well, we ended up rejecting the claim. And either you would say that the test statistic was greater than the critical value, so we would accept the null, or we would say that the p-value was greater than your alpha value. So again, we accept the null, which means we're going to reject the claim. So on the next one, we are now going to do our hypothesis test for our z distribution when we have just the statistics instead of having to type all our data in there. So basically our steps are going to be the same, other than we don't have to enter our data. I'm going to grab my graphing calculator here. I'm going to hit stat. I'm going to cursor over to tests. I'm going to do number 1, which is my z-test. So this time, instead of having the data, I want to highlight stats and hit enter, so my cursor is blinking on the word stats. So at a 5% significance level with a given average mean of 42,000, test the claim that the mean is greater than 42,000. Given that our population standard deviation is 5,230, our sample mean is 43,260, and n was the number of people we sampled. So my mean on my claim is 42,000, so I'm going to put in 42,000. My standard deviation was 5,230. My sample mean, 43,260. And the number of people were 30. We are going to test the claim that the mean is greater than, so we want to highlight the greater than one. And once we have that information in there, we can go ahead and calculate. So my null hypothesis would be that the mean is less than or equal to 42,000, because the null also always has to contain the equal. My alternative hypothesis is what we have in there, that the mean is greater than the 42,000. My value of my test statistic is my z-value, 1.3195, so I would round that up to 1.320. 1.320. My p-value, 0.093. 0.093. And then it wants to know if this is a left-tailed test or a right-tailed test or a two-tailed test. In this case, since the mean is greater than 42,000, we're doing a right-tailed test. So it wants to know next, what is the critical value? And so I don't want to clear out my graphing calculator. I'm going to slide or look over here at the Aleks Calculator. So I'm doing the Aleks Calculator here for my critical value. I'm going to do the z-sub. It's positive because I'm doing a right-tailed test. So 0.05. If I calculate that, my critical value is going to be at 1.645. 1.645. So, question wants to know, should I accept or reject the claim? So again, there's two ways I can compare those things. I like to draw the picture, so I'm just going to bring that up again. So, my critical region value was 1.645. Since I'm doing greater than, the alternative hypothesis would be to the right. Less than to the left then would be my null hypothesis. My value for my test statistic was 1.3196. That falls on the left side, so it's falling in the section for the null. That means I'm going to accept the null, which means I would reject the claim. My other way that I can compare that is comparing my p-value. My p-value was 0.0935. Since that is greater than my alpha value of 0.05, again, I would accept the null since the p-value is greater than the alpha value. And if I'm going to accept the null, that means I'm going to reject the claim because the claim was the one that says, is it greater than or not? And so either way I test it, using the critical value or by using the p-value, I'm going to end up rejecting the claim that my mean was greater than 42,000. All right, so if I go to the next page here, I have one from Aleks. It says, The breaking strength of the cable produced by my certain manufacturer has a mean of 1,925 pounds and a standard deviation of 90 pounds. It is claimed that an improvement in the manufacturing process has increased the mean breaking strength. To evaluate this claim, 70 newly manufactured cables are randomly chosen and tested, and their mean breaking strength is found to be 1,952 pounds. We want to know, can we support at the 0.05 level of significance the claim that the mean breaking strength has increased? Perform a one-tailed test. We are going to perform a one-tailed test because we want to see if it has increased. So is the mean greater than the 1,925 pounds given in my problem? So I'm going to slide this over here. And if we look at this problem, the null hypothesis here would be, is the mean less than or equal to, let me insert my symbol here, is my mean less than or equal to the mean that was given up here, 1,925. My alternative hypothesis is what the claim is, which means is the mean greater than 1,925. This is the claim. Right? Can we support the claim that it has increased? Now we're going to use the graphing calculator in order to find these values. So you are going to press the Stat button. You're going to go over to Tests, and you're going to do the Z-test. We're going to do Statistics. And so the mean value is going to be the 1,925. The standard deviation was 90. The sample mean was the 1,952, and the number of people that were surveyed was 70. You are testing the claim that it is greater than, so again you want the greater than, and you're going to calculate that. I'm not going to go any further than that. I'm going to have you calculate that. Write down your T statistic to 3 decimal places, your P value to 3 decimal places. Decide if it's a left-tailed test, a right-tailed test, or a two-tailed test. And then you'll have to calculate the critical value. You can either use your graphing calculator or use the Aleks calculator to find that critical value, and then decide, should we accept or should we reject that claim? So next we're going to do hypothesis testing for the mean and the t-distribution when you don't know the population standard deviation, but you do know the sample standard deviation. Again, when we do this, you may have a list of data or you may just have the statistics. So if you have the list of data, you're going to have to type the data into list 1 by hitting Stat and 1 to edit. Then press Stat and move to the test menu, and this time we're going to put 2 for t-tests. Move your cursor to data if you have the list and enter and type in your appropriate values. Move your cursor to the appropriate alternative hypothesis and enter and then calculate. Again, just like on the previous ones, when you do your comparison, you're going to have to find your critical values. And to find your critical values for the t-statistics, which is what we did in Chapter 6, you can either use your graphing calculator or your Aleks calculator. Aleks calculator is probably a little bit easier, but just to remind you, on the graphing calculator, again, we're hitting second, the distribution menu, which is on the vars key. This time we're going to hit number 4 for the inverse t, in the form of the area to the left and then the degrees of freedom. So remember, if you're finding the area to the right, you're going to do 1 minus that alpha value. So just for an example quickly, since we've already done this in Chapter 6, to find the critical value for the right-tailed test with an alpha value of 0.05 and 12 degrees of freedom, we are going to grab our graphing calculator here. We are going to hit the second button and then the vars key for the distribution menu. This time we're doing choice number 4, which is your inverse t. So I'm going to hit number 4. And then in for your area, since it's the area to the right, I'm going to do 1 minus 0.05. You could just subtract and use 0.95. We have 12 degrees of freedom. When I paste that into my formula, then, and I enter, I get 1.7822879494. Again, they'll probably have you rounded off to 3 or 4 decimal places. On the Aleks calculator, it's always going to do the area to the right. So if you want the area to the left, you use the negative t sub. If you want the area to the right, you just do the t sub. So in this case, I'm going to do t sub 0.05 since I'm doing the area to the right with a degree of freedom of 12. And when I enter, you can see I got that exact same answer, 1.78228 and so forth and so on. So the Aleks calculator is probably a little bit easier to find that critical value than the graphing calculator. If you want to the right, you use the positive. If you want to the left, you use the negative. I won't have you do any practice ones on that because we did that in Chapter 6. All right, so now we're going to do some hypothesis testing for the t distribution. So on my example problem for my t distribution, it says the average monthly cell phone bill was reported to be $50.07 by the U.S. wireless industry. Random sampling of a large cell phone company found the following monthly cell phone charges in dollars. So again, we're going to have to put that into our calculator into list 1. So I am going to hit the stat button. And when I hit the stat button, I'm going to edit. And so I'm going to put number 1. And then I'm going to go ahead and type my values in. I again went ahead and typed the values. Again, if you have other values, if you go up and highlight L1 and then hit clear and enter, it will clear your data. I don't want to do that. But go ahead if you need to, pause the video for a minute, get your data typed into list 1. Once you have your data in list 1, we are going to do our test again. So we are going to hit this word stat, hit the button stat. We're going to go over to tests. This time we're going to do a t-test. Since we don't know the standard deviation, we are going to hit number 2 for the t-test. We're going to use the data since we typed the data in. On this one, it said that the mean value was reported to be $50.07, so I've typed in my $50.07. My list I'm using is list 1, frequency going to stay 1, and then I want to highlight the one I'm doing. I want to see if the average bill has increased, and so I want the greater than highlighted, and then I'm going to calculate. So when I hit calculate there, it's going to give me my values. So on there, the value of my test statistic, my t-value, is 2.741. My p-value, 0.011. And then it also gives you your sample mean and sample standard deviation, and that we had 10 numbers in our list. So we have our values there. So once we have our values, we want to know, is this a left-tailed test or a right-tailed test? In this case, this is going to be a right-tailed test because we are checking to see if our mean is greater than 0.07. Then it wants to know what the critical value is for my alpha value of 0.05. So again, the easier way to do it is to use your graphing, or to use your Aleks calculator. I'm going to clear this out, do the t sub. In this case, I'm doing a right-tailed test, so I'm using the positive t. And so I am going to use 0.05. And my degree of freedom, since I had 10 things in my sample would be that I have 9. So my degree of freedom is n minus 1. I had 10 in my sample, so 10 minus 1 would be 9 for my degree of freedom. So if I enter that in there, you can see that my critical value is 1.833. 1.833. Now if I use my graphing calculator again, I would do the second function button, hit the vars key for the distribution menu, and I'm going to do inverse t, and so number 4. And so I wanted the area to the right, so I'm going to do 1 minus the 0.05. My degree of freedom on this problem was 9. If I paste that in and to my formula and enter, you can see that I get the same answer as I got on the Aleks Calculator, 1.833. So my critical value is 1.833. It wants to know then at the 0.5 level of significance, should we accept or should we reject the claim? So again, I like to draw pictures, so I'm going to bring up my picture here. My critical value was 1.833. My test value for my t-value was 2.741. The 2.741 was greater than the 1.833, so I'm in the section where I would accept the alternative claim. And so I'm going to accept my claim that the mean is greater than the 50.07. Now the other way I can compare to decide if I should accept or reject the claim is compare the p-value. My p-value was 0.0114. Since 0.0114 is less than alpha, which was 0.05, if it's a less than, I'm going to reject the null. If I reject the null, that means I'm going to accept the alternative hypothesis. And so either way, we will accept the claim that it is greater than the $50.07. So on the next one here, we are going to do one where we have the statistics. It says, the average local cell phone call length was reported to be 2.27 minutes. A random sample of 20 phone calls showed an average of 2.98 minutes in length with a standard deviation of 0.98 minutes. At a significance level of 0.05, can it be concluded that the average differs from the population average? So if I'm trying to figure out if it differs, my null hypothesis is the mean equal to 2.27. My alternative hypothesis is the mean not equal to 2.27. So if we're going to use our graphing calculator in order to figure out that data, again, on our graphing calculator, if we know the statistics, we're just going to hit the stat button. And when we do the stat button, we're going to do the tests. And we're doing a t-test in this case. And this time we're going to use the stats instead of using data that we typed in. So we're going to hit stats. The given mean that we had was 2.27. The mean from our sample was 2.98, and the standard deviation from our sample was 0.98. A random sample of 20 people were selected, and so we're trying to see if it differs, so we're going to use does not equal. So when we calculate, you can see that our t-value then, the test statistic, is 3.240. 3.240. Our p-value, 0.004. And then, again, when we are figuring this out, first of all, we want to know, is this a left-tailed test or a right-tailed test or a two-tailed test? In this case, we're doing does not equal. It's going to be a two-tailed test. We want to know the critical value for alpha being 0.05 for our significance level. So again, if I am doing a two-tailed test, I'm going to divide that by 2. So again, on our graphing calculator, our calculator on Aleks, it's probably a little bit easier to do. I'm going to go over here and clear this out. I am going to do t sub. I'm going to use 0.05 divided by 2 because I'm doing that two-tailed test. My degree of freedom, I had a sample of 20, and so my degree of freedom is going to be 19. So when I enter that in there, you can see that I get 2.093. So I'm going to use plus or minus that 2.093 since I'm doing my two-tailed test. So again, if you were going to do that on your graphing calculator to find your critical value, you are going to use the second function button and the vars menu to get the distribution menu. We're going to do inverse t, which is choice number 4. And so for the area, we're going to use 0.05 divided by 2. My degree of freedom again was 19. And when I enter that in, you can see that I get the negative value because I used the area to the left, the negative 2.093. Again, you're going to have plus or minus that value because you're doing a two-tailed test. And so I'm going to use negative 2.093 and positive 2.093 for my critical values. So the question then again is, should we accept that claim or not? So again, 2 ways to accept the claim or not. I'm going to look at my graph here. I've drawn a picture. I have my critical values of negative 2.093 and positive 2.093. My t-value, my test statistic, was 3.240, which is bigger than the 2.093. So it falls in where we would accept the alternative claim. So we're going to accept the alternative claim, which is that it was not equal. So are we going to accept the claim? Yes. We are saying that the mean does not equal 2.27. Now we're going to try one from Alex. It says a rental agent claims that the mean monthly rent for apartments on the east side of town is less than $725. A random sample of 16 monthly rents for the apartment on the east side has a mean of $715 with a standard deviation of $19. If we assume the monthly rents for the apartment on the east side are normally distributed, is there enough evidence to conclude at the 0.1 level of significance that the mean is less than 725? So in this case, my null hypothesis is that the mean is going to be greater than or equal to 725. My alternative hypothesis, which is my claim, is that the mean is less than 725. We're going to do the t-test because we know the sample standard deviation, not the population standard deviation. And the degree of freedom, since we have 16 monthly rents, is going to be 16 minus 1, which is 15. So again, I am going to have you go ahead and put that in your calculator and calculate that one. So again, you are going to hit the stat button, cursor over to tests, and you are going to do the t-test, so you are going to do number 2. And so when you input your data there, your mean on this one was 725. The sample mean was 715. The sample standard deviation was 19. N is that you had 16 monthly rents, and you are trying to figure out if it is less than 725. So go ahead and calculate that and then see if you can answer the rest of the questions. What's your test statistic? What your p-value is? Is it a left-tailed test, a right-tailed test, or a two-tailed test? What are your critical values? Again, when you're doing your critical values, probably easier to use the Aleks Calculator. And then decide, should you accept or reject the claim that the mean is less than 725. We're also going to do a hypothesis test for a proportion. So on our graphing calculator, again, we're going to go to Stat, cursor over to Tests. This time we're going to go to number 5, which is the one proportion z-test. We're going to enter in our appropriate values, pick our alternative hypothesis, and do calculating. So again, we're going to have to find the critical value, and when we do this one, when we do the hypothesis test for proportions, we use the z-test. So for the z-test, you are going to use second distribution menu, which is on your vars key, and use inverse norm. And on the Aleks calculator, you would do z sub, either positive z sub or negative z sub, depending if you're going to the left or the right. And so I'm not going to have you calculate that again since we just calculated it on when we did the z-test, but just reminding you that that's how you would do that. All right, we're also going to do a hypothesis test for proportions. So to get to that, you do the stat button, cursor over to tests. Number 5 is going to be your proportion z-test. Type in your appropriate values, move your cursor to the alternative hypothesis, press enter, calculate, and press enter. Again, when we do this, we're going to have to find the critical values for our z-test. And so on our calculator, second function distribution menus on the vars key, and number 3 for inverse norm because we're finding the z value. You put the area to the left of the z-score, and then of course we're going to have 0 for the mean and 1 for the standard deviation. If you are doing the area to the right, you're going to do 1 minus alpha. On Aleks, you're using either the negative z sub or the positive z sub. We did this at the beginning, so I'm not going to have you recalculate those, but just to refresh your memory that we're going to do that. Again, the Aleks calculator is probably easier, that we can just use the z sub if we're going into the right or negative z sub if we're going to the left. So for our proportion test, it says test the claim that 40% of all telephone customers have call waiting. When n is 100 and p hat is 37%, use alpha or your significance level as 0.01. Now I'm going to grab my calculator here, and so I am going to go ahead and hit the stat button. So if I hit the stat button, I'm going to again cursor over to tests, and you can see that number 5 is your one proportion z-test. So we're going to do number 5. And here when we do our menu, the P is the probability of the claim, which you're going to use 0.40 for 40%. The X value is kind of weird. The X value is your P hat value, and instead of using 37%, you're just going to use 37. So I'm going to type the 37 in there instead of 0.37. So you have to be careful on that. N is going to be 100, and then we are testing that it is not equal to the value because we wanted to test if 40% of all the telephone customers have call waiting. So if they have call waiting, that is going to be my null hypothesis. Does P equal 40%? If they do not have call waiting, P does not equal that. So we're going to pick does not equal. We're going to go down to calculate, and we can see that our values for our test statistic, our z value is negative 0.612, negative 0.612. I better move that over so you can see. Negative 0.612. My p-value, 0.540, 0.540. P hat, 0.37. Now you see that it's 37% there, and n is 100. So you may have to calculate your n value in this case because it was out of 100. 37% of 100 was 37, and that's why we used that x equaled 37. Wants to know if this is a left-tailed test, a right-tailed test, or a two-tailed test. This would be a two-tailed test because we're using the not equal. And then we have to calculate our critical value. So when we do our critical value, again, probably the Aleks calculator is easier. We're going to do z sub. We're using a 0.01 significance level, but because it's a two-tailed test, we have to divide it by 2. So our critical values are going to be plus or minus 2.576 when I round that off. Plus or minus 2.576. We are then going to decide there if we should accept the claim or not. And so when I look again at my drawing, I have a two-tailed test. My critical value, negative 2.576 and positive 2.576. My test value was negative 0.6124. Negative 0.6124 would fall in the middle section between the negative 2.576 and the positive 2.576, which means we should accept the null. In this case, the null was our claim. Our claim was, does it equal 40%? And so, are we going to accept the claim? Yes, we are going to accept the claim because it falls in the null, and the null was our claim on this one. So you have to kind of pay attention to, is it the claim or is it not the claim? Which one is? Because most of the time, your alternative one is your claim. But in this case, the claim was actually the null, and we are accepting the null. So if we do one from Aleks, it says, a presidential candidate's aide estimates that among all college students, the proportion P who intended to vote in the upcoming elections is at least 60%. If 137 out of the random sample of 245 college students expressed an intent to vote, can we reject the aide's estimate at the 0.5 level of significance? So here the question is asking us if we can reject the claim instead of accept the claim that like we normally have asked. So you kind of have to watch on Aleks because sometimes they will switch that around. We are going to perform a one-tailed test, the null hypothesis, because the claim says is it at least 60%. At least would be greater than or equal to. So my null hypothesis is that P is greater than or equal to 0.60. My alternative hypothesis then would be, is P less than 0.60? So P is either greater than or equal to 0.60 for my null, or P is less than 0.60 for my alternative. So my claim here was, is it at least 60%? So then we need to do our calculations. So again, this one, I'm going to, again, hit the stat button in order to get to my tests. I'm doing number 5 because I'm doing the one proportion z-test. And on this one, we want to know if it's at least 60%, so we're going to use 0.60. Here we don't have to calculate that. Remember on the previous one it said 37% of 100 and we used the 37. On this one it just tells us 137 out of the 245. So X is the 137, N is my 245. When I'm doing my comparison, my alternative hypothesis is going to be less than, since my null hypothesis was the greater than or equal to. So I'm going to pick the less than. Again, I'm not going to do the calculate. I'm going to let you calculate that and then decide the rest, the answers to the rest of the questions. What's my test statistic? What's my p-value? Is it a left-tail test, a right-tail test, or a two-tail test? What are my critical values at the 0.1 level of significance? Whoops, wait a minute. I need to fix that. What are my critical values at the 0.5 level of significance? And if my level of significance is 0.5, should we accept or reject the claim? Or the question actually says, can we reject the claim on Aleks? But should we accept or reject the claim in this case? So go ahead, figure that one out.